if you want to take a vacation, take it before that date, because who knows what will happen.
3 days. That's all we have left before something extraordinary happens behind our sun. An object, 33 billion tons, traveling from beyond our solar system. And right now, we can't see it. Every telescope on Earth, blind. But here's what terrifies scientists. This thing isn't behaving like anything we've seen before. It's emitting industrial chemicals, it's defying physics, and it's following a path that seems designed. The crazy part? We can't see it. Our telescopes are blind. Every single one of them. And here's what keeps me up at night. A Harvard professor just said, if you want to take a vacation,
Take it before that date, because
who knows what will happen. Let me take you back 5 days. October 21st, an object called Atlas positioned itself on the exact opposite side of our sun. Relative to Earth, it became completely invisible. Every telescope on our planet, every observation network we have, useless. If this kind of space mystery grabs you, like this video, and subscribe now for more space mysteries and updates. Now, Atlas isn't just any space rock. It's only the third visitor from beyond our solar system that we've ever detected. Think about that. In all of human history, we've only seen 3 objects from interstellar space pass through our neighborhood. The first one, Oumuamua. That thing caused chaos in the scientific community back in 2017. The second, Borisov, a regular comet, nothing special. But Atlas? Atlas is different, very different. Right now, it's approaching perihelion. That's the closest point to our sun in its trajectory. And when I say close, I mean 1.35 astronomical units. So why is everyone freaking out about Atlas? What makes it so special? Well, let me tell you about the anomalies. And trust me, each one gets more disturbing than the last. Anomaly number 1, the impossible path. When Atlas was first discovered, astronomers immediately noticed something weird about its trajectory. This thing is traveling along a path that's aligned to just 5 degrees from the ecliptic plane. Now, if you don't know what that means, let me explain. The ecliptic plane is like a flat disk where all our planets orbit. Earth, Mars, Venus, Jupiter, they all move roughly on the same level. For an object coming from interstellar space, from outside our solar system, the probability of randomly entering on this exact path? 0.2%. That's not just unlikely, that's astronomically improbable. But here's where it gets creepy. If you were an engineer and you wanted to design a mission to visit multiple planets in our solar system with minimum energy, you would choose exactly this path. The ecliptic alignment gives you perfect flyby opportunities. Mars, Venus, Earth, Jupiter, all lined up like stations on a train route. Coincidence? Maybe. But wait, there's more. Anomaly number 2, the chemistry that shouldn't exist. In July, the Keck 2 telescope in Hawaii captured something that made scientists go silent. Atlas was emitting nickel. Now, you might think, so what? Space rocks have metal, right? Wrong. Not like this. The nickel emission pattern from Atlas matches something very specific. On Earth, this exact signature only appears in highly controlled industrial processes. We're talking about alloy production, about the carbonyl process used in factories. Natural comets don't do this. They can't do this. But there's more. Atlas is also releasing cyanide. And here's the weird part. The nickel is concentrated in a 600-kilometer region of the nucleus, while the cyanide extends for 840 kilometers. If both were naturally sublimating from ice, boiling off because of the sun's heat, they should follow similar patterns based on how volatile they are. They don't. The nickel is acting like it's part of an organized structure. Not random evaporation, not natural behavior, something else. Anomaly number 3. The water that isn't there. Okay, this one really messed with my understanding of comets. Comets are basically dirty snowballs, right? Ice mixed with dust and rock. Water should be the dominant component. That's Comet 101. But Atlas? It contains only 4% water by mass. 4%. That's revolutionary. That's game-changing. Because if it's not mostly ice, then what the hell is it? Remember Borisov? The second interstellar object we detected? That one had typical water composition. It was a normal comet. Everyone agreed it was natural. So why is Atlas fundamentally different? And there's another thing, the polarization of light. The way light bounces off Atlas's surface is extremely negative. This phenomenon has never been observed in any known comet, including Borisov. It's like Atlas has unique surface properties, something we've never encountered before. Anomaly number 4, the unbelievable mass. Let me give you some numbers that will blow your mind. Atlas is estimated at 33 billion tons. That's 1,000 times more massive than Borisov. That's 1,000,000 times larger than Oumuamua. With a minimum diameter of 5 kilometers, this thing has sufficient mass to carry significant payloads through interstellar space. Think about that for a second. If you wanted to transport something across the galaxy, probes, equipment, whatever, this object could carry thousands of small probes or hundreds of larger structures and still maintain structural integrity. It's basically an interstellar cargo ship in terms of capacity. Now, I'm not saying that's what it is, but physics allows it. The mass is there. Anomaly number 5, the anti-tail mystery. Between July and August, astronomers observed something that defied physics. Atlas developed an anti-tail. Material was being ejected toward the sun. Let me repeat that. Toward the sun. That's the opposite of how comets work. Solar radiation should push material away, creating a tail that points away from the sun. That's basic physics. But Atlas? It was shooting material against solar radiation pressure. Scientists checked. They analyzed. They confirmed it wasn't just a perspective illusion. Material was genuinely being ejected in the wrong direction. This suggests active internal processes, energy sources inside the object, mechanisms we don't understand. And all 5 of these anomalies, they're happening in the same object. 1 anomaly? That's interesting. 2? That's unusual. But 5? That's a pattern. So here's where things get really interesting. Avi Loeb, Harvard professor and former chairman of the astronomy department, created an evaluation scale. A scale from 0 to 10 for potentially artificial interstellar objects. 0 means definitely natural. 10 means definitely artificial. Where does Atlas score? 4. Not conclusive, but significant enough to justify serious investigation. And that's exactly what's happening right now. For the first time in history, protocols normally reserved for extinction-level threats have been activated. The International Asteroid Warning Network, IAWN, they exist for one purpose only: to detect and track objects that could wipe out civilization. They don't waste resources on interesting scientific curiosities. They don't monitor every random space rock, but they're monitoring Atlas. A 3-month intensive campaign started on October 27th, 2 days before perihelion, and it will continue until January 2026. Here's the paradox that keeps me awake. Atlas is not on a collision course with Earth. Its closest approach will be 1.8 astronomical units away. That's farther than Mars. There's 0 possibility of impact. 0. So why activate planetary defense protocols? Why treat it like a threat? What do they know that they're not telling us? And speaking of not telling us things, let's talk about NASA. On October 3rd, NASA's Mars Reconnaissance Orbiter captured the highest resolution images of Atlas. The object passed 190 million kilometers from Mars, and the HiRISE camera got a perfect shot. These images have 30 centimeters per pixel resolution at that distance. That's 3 times better than the best Hubble Space Telescope images. These are the most detailed photographs of Atlas in existence, and they remain unreleased. Avi Loeb has publicly requested access. Multiple times, blog posts, direct emails to NASA. The response? Silence. Complete, deafening silence. Now, contrast that with the European Space Agency. They've been relatively transparent. The ExoMars Trace Gas Orbiter imaged Atlas and released the data. The images show a classic comet appearance, diffuse point with a small tail. Nothing alarming, right? But when you examine the spectroscopic analysis of that same data, you see the anomalous chemistry. You see the nickel. You see the patterns that don't make sense. So ESA is showing us the pictures, but the pictures don't tell the whole story. And NASA? They're not showing us anything at all. What did they see in those high-resolution images? What are they hiding? So what is Atlas? What are we actually looking at? Physics allows multiple explanations. Let me walk you through them. Scenario 1. Exotic natural comet. Maybe Atlas is just a comet with unusual composition. formed under radically different conditions from our solar system. Other stellar systems have different metallicities, different formation temperatures, chemical processes that simply don't occur here. The nickel emissions? Natural carbonyl processes in the nucleus, spontaneous chemical reactions under specific conditions. The low water concentration? It formed in a volatile pore region, maybe near a young, hot star. This explains the chemistry, but it struggles with the orbital alignment and the perfect timing. Coincidences happen, sure, but multiple simultaneous coincidences? That tests statistical credibility. Scenario 2. Controlled fragmentation. The object might be disintegrating in a highly organized manner, releasing internal components with distinct properties. Internal structures preserved for millions of years in interstellar cold, now beginning to sublimate when exposed to intense solar radiation. This would explain the anomalous emissions, the composition variations, the anti-tail. Scenario 3. Active orbital maneuver. Here's where it gets wild. If some process alters Atlas's velocity during perihelion, we would see measurable orbital changes in the following weeks. A deceleration of just a few kilometers per second would be sufficient to keep the object permanently in our solar system. And perihelion offers the ideal energetic window. It's the moment of maximum orbital velocity. Any applied impulse gets amplified by orbital mechanics. It's called the Oberth effect. We use it for all our interplanetary missions. Scenario 4. Ejection of components. With its mass of 33 billion tons, Atlas could eject thousands of smaller objects and still maintain structural integrity. What if it's releasing something during maximum perihelion heating? Fragments, probes, components we can't even imagine? The scientific community is deeply divided about Atlas. Jason Wright, astronomer at Penn State, published a devastating critique. He systematically dismantled each of Loeb's proposed anomalies. On the supposed absence of coma, Wright argues Loeb misinterpreted telescope tracking. When you track a moving comet, you keep the nucleus sharp while the background blurs. Of course, you don't see diffuse coma clearly. On size calculations, Wright says Loeb assumed asteroid albedo, 5% reflectivity, to maximize size estimates. If Atlas is a comet, it would have a smaller nucleus surrounded by bright coma. Not the giant mass, Loeb calculated. Loeb fires back. He argues his critics are so invested in conventional explanations that they reflexively dismiss anomalous evidence. Science has a conservatism problem, he says. Paradigm shifts are resisted. Outsider ideas are dismissed too quickly. Wright accuses Loeb of bypassing peer review, publishing directly in blogs and interviews before submitting formal papers. Avi Loeb responds, "The peer review system is too slow for transient phenomena. Atlas won't wait months for editorial committees to deliberate." Who's right? We don't know yet. Betting markets currently place odds at 75% natural comet, 25% artificial origin. There's no consensus, just deep uncertainty unfolding in real time. So, what happens next? When do we get answers? We have 3 critical windows, 3 moments that will definitively resolve the Atlas mystery. November 4th, the JUICE flyby. The European Space Agency's JUICE probe will make the first post-perihelion observation. It will pass 64 million kilometers from Atlas. This is our first opportunity to see how the object changed after exposure to 33 gigawatts of solar radiation. If Atlas executed a maneuver during perihelion, the effects will be obvious. Velocity changes of just meters per second will be measurable. December 19th, maximum Earth approach. Atlas will pass 1.8 astronomical units from Earth. All major ground-based observatories will be pointed at it. The James Webb Space Telescope will detect thermal signatures and molecular composition in extraordinary resolution. This is when we'll see the full picture. The chemistry, the structure, everything. March 16th, 2025. Jupiter encounter. Atlas will pass 54 million kilometers from Jupiter. NASA's Juno probe will provide frontline observations. If the object released smaller components during perihelion, some might be on trajectories that bring them near Jupiter at this time. Each window builds upon the previous one. The question is elegantly simple. Will Atlas's trajectory change? If it follows pure gravitational laws, we'll confirm that interstellar comets can have surprisingly diverse properties. We'll learn about formation processes in other stellar systems. But if orbital, deviations appear. If non-gravitational accelerations are detected, If multiple components emerge where we expected only one, we'll face a new type of phenomenon, not necessarily artificial, but definitely something outside our previous experience. Right now, as you're watching this, Atlas is behind our sun. 33 gigawatts of energy are bombarding its surface. Processes that may redefine our understanding of the universe are occurring, and we can't see any of it. In 3 weeks, the blackout ends. Telescopes will reacquire the object, and then we'll know. The beauty of science? Nature always has the final word. And Atlas is about to speak. So here's my question to you. What do you think Atlas really is? Natural comet or something else? Drop your theory in the comments. Hit subscribe, because when those November results come in, you'll want to be here. This is just the beginning.